So one of the things that's used very extensively in Linux kernel modules or the development of it are the make files, right? Of course, there are many other ways in which people go about building their modules, but Makefile is, well, I would say at the heart of it all. So we're going to take a look at the Makefile and some, basics that you should be aware of, right? These are like good to know because they come up like again and again, and they're also kind of useful in terms of debugging the Makefile or debugging your own modules build flow. So then, let me pull up the whiteboard here, and we are going to take a look at, as part of this video or this lecture, make and Makefile, right? And what are like the link between these, right? So first off, make itself, like all lowercase, make is a utility. And what does this utility help us with? It helps us with automation, right? And automation of what? Automation of kind of, executing, commands, right? Commands of what nature? Everything that we can write on the shell, so those commands can be automated. So anything that we were going to execute on the shell, on the terminal, that the make can do it for us. So for example, if you're aware of how we go about compiling a C file, then we say, hey, GCC, take our file main.c and then output it. Okay, just a moment. So we say then output it as, let's say, main. Right. And so this command usually we type on the terminal. So the idea then is we can have make execute this command for us. Right. So that's what I meant when I said that the commands we can execute on the terminal, we can also execute them using make. Now, where does make become useful? So when you have like lots of these commands to be typed like one after the other, let's say 5 or 10 of those, then each time doing that manually, typing, the 5 commands or 6 commands, become tedious, repetitive, boring, and it's subject to human errors also. So to avoid all of that, we can create like a recipe, and then ask make to execute that recipe, execute these commands for us, right? And then the question is, how do we kind of specify those recipe, and that's where the concept of make file comes in, right? And in this make file, this M here, the first letter in the, or first alphabet in the name, has to be uppercase, right? So the idea then is whenever we execute make followed by something, and what this something is will come to in a while, but let's say we execute make, the make utility goes searching for exactly this file. And it'll open up this file and process the data given inside of it, and then kind of, infer what commands to execute, and then go ahead and execute those. Right. So that's that then. Make is a utility for automation, followed by something, and this something, by the way, is called target, right? And so make will go looking for information about this target in the make file with an uppercase M. Now, of course, you can have any name to the file and then end it with .mk, and then the idea is that we have to, while calling makefile, tell it that, hey, the file that we are wanting or you to use in terms of searching the details of the recipes, we are specifying it with the -f option followed by the name of the file and then the target, right? And what target is, we'll come to that in a minute, but then execute the target. And so now make will not search for this make file, but it will go looking for this file name. And as soon as it finds this file name, it will open it up and look for information about how to execute this target, right? And okay, so if this much is clear, then we can come back to how this .mk or Makefile are written. How are these authored? What are the syntax and the rules? So the first thing is it can have many targets, right? A target is essentially, you can think of it as a short name for a complete set of commands, right? So the usual format is we have to specify the target followed by a colon, and then we can specify dependencies rather, right? So for example, here the GCC command depends on the existence of main.c. So in dependencies we can mention main.c. Now all the dependencies go on the first line then, and the recipes or the commands to be executed start from the next line. And then the idea is that there has to be a mandatory tab character here, and then we specify the command that needs to be executed, right? And if there are multiple commands to be executed, they can go on new lines, each starting with a tab, right? Each starting with a tab, and we'll see an example of this in a while, but that's the idea. And then you can have another target, and so on and so forth. The dependencies may or may not be there. For example, in our case, the clean command here, for example, and even the all doesn't have any dependency, right? Which is all right, because if you just want a target to be associated with bunch of commands, well, then that's that. Now the idea of dependency is that make is smart enough that if the dependencies have not changed, then it will not regenerate or re-execute the recipe. So for example, what I mean by this is, let's say x.c is used to generate x.o, for example, right? And then we have a target called xyz, and the target name can be anything. It just needs to start with an underscore or a alphabet, right? And you can play around with the names of the target, but the target, and then in this dependency we say, hey, it depends on a.x, right? And as part of the recipe, then we say a tab character here, and then followed by gcc minus, oh, well, okay, let me do this here. So x.c minus o, x.o. Let's say this is our command. So for the first time that we call make xyz, and notice that this is the target. So it will go ahead, look at this and say, hey, it depends on xyz. Do I have xyz? Sorry, it depends on x.c. Do I have that file x.c? It's like, yes, I do. Fine. Okay. And now, it'll then go ahead and execute this command. And actually, let me change this a little bit, because then it kind of makes a lot more sense. Let's say we want it to be output as xyz, right? Let's just call it this way. So when we are executing this target, it first says, hey, does the x.c exist? Yes, it exists. Also, is this file older than my output? First off, does the output exist at all? If it doesn't exist, then it knows that it must generate it, right? So the first time we execute this command, xyz will be generated, right? First time. The second time we just try again, then what make will say is, hey, I see that x.c exists, and so does xyz, and xyz looks newer than x.c. And if this is newer than x.c, then nothing in x.c seems to have changed. And if nothing changed in x.c, it doesn't go ahead and execute this. So that way make saves us effort also. It only updates what the dependencies of which are updated or changed. So now if we go ahead and make some change in x.c and run the make command, make xyz again, now it notices that, hey, this xyz file, yes, it exists, and it's older than x.c, which means this needs an update. So that is also another kind of benefit of using make and make files, which is it only compiles or regenerates the output files that are stale, so to speak, right? All right, so just reiterating, the format of makefile is target colon dependencies. Then on the next line, a tab character, and this tab is mandatory. It should not be 3 spaces, 4 spaces, 2 spaces, none of that. It has to be a tab character. And then you can have command 1 here, command 2 here. Okay, my spelling is messed up here. Command 2, and so on and so forth. Right. So that's the idea of make, and make can. It also has notions of variables and whatnot. Right. Variables, functions, this and that. But this is the basic syntax. If you know this, you'll be able to make sense of what's going on, and what might not be working. Okay, let me get this out of the way. And now if you look here, right, so this here is the all target that does not have any dependency, which is fine. Then we have a tab character here, which cannot be seen, but trust me, it is tab. If I convert it into spaces, the make file won't work. The make utility won't work. Now this doesn't have any dependency. The name is clean. The target name is clean, and the command is right here. So what I'm going to now do, okay, one other thing I should have called out is when we execute make, when we simply call make, it will look for the make file with a like a uppercase M, and it will execute the first recipe available. Right, it will execute the first target. If we specify the target, it will go after that. Right. So that is the idea of make then. And what you see here at this point, this is essentially just a variable, right? So this right here, objm plus equals to essentially means amend. So objm will already be like, many things. And then we are saying, hey, add ldd.o at the end of it. Right. And variables are like a different ball game, but just know that make also has this notion of variable, and it can, it can simplify life. Okay. So now what I'm going to do is just for the sake of demonstration, I'm going to add ldd.c here. So all depends on ldd.c, and let's go ahead and execute make. So, make has executed the command, carried out all of these execution. Now note that we are not going to change anything in ldd.c. And so when I execute make again, it should somewhere say that the targets are updated. Okay, in this case it doesn't say, but what it doesn't say specifically, but what it is doing here is it has not executed or generated all of these output files, right? And let me then go ahead and maybe just put like a space here. So now ldd.c is modified, and once it's modified, you will see that it has again regenerated all the outputs as it was here. And also, if you notice, it would have generated only, okay, turns out everything was regenerated, not a problem. Perfect. So this is, so to speak, the dependency. And let's try out one more thing. So let's say we are wanting to generate test.text, and it depends on test.c. And here's the tab character. If you see, it's a tab character right here. And then what I'm going to say is, hey, first off, cat the uh, test.text file. And then, by the way, cat test.text again. And then after that, push it in, oh, sorry, text.c, then push it into test.text. Oh, right? And then after that, cat test.txt, right? So notice that there are 3 commands that it will execute on the terminal. Each one of them starts with a tab character. And what I'm going to now do is, first off, execute make clean, so everything is out of our way. And I'm now going to write test.c here, which simply has, I don't know, hello test, right? Let's say it only has this. I'm going to save this file. All right. So now if I do make test.txt, so notice that this is the target, this is the dependency, and these are the commands. So what we should see here now is this, and this command getting executed. And this should again reconfirm to you that make is executing the three commands for us, which otherwise we would manually execute. Right. So let me go ahead and execute this. And if you see, the first command it executed was this, same as this. The output is available here. Then after that, it went ahead and executed this command, right? And then after that, it executed this command, the output of which is this. And we started off with test.c. We also now have the file test.txt. Now, as I mentioned earlier, if I try to execute this command again, it says, hey, I need not do anything because test.txt is already at its latest version because test.c did not change, right? And now I'll go ahead and, um, uh, hello again, I'll just modify it. So now test.c is modified. So this is newer compared to this file. And so these commands should get executed again, right? So let me just go ahead and do that. And if you see, lo and behold, it kind of, executed these commands again. And obviously the content of test.txt, because of this line here, is same as the, the content in test.c. Right? So hopefully you're convinced that make is used for, make is, oh, sorry, my bad. This has to be, yeah, lowercase. Make is used for automation, uh, whatever the spelling is, automation, and then .mk is file extension if it's not named as Makefile. And Makefile, the M here has to be uppercase. This is the file that make by default goes looking for. And then within this file, or within this file, the .mk file, the recipe is target colon dependencies, on the next line, tab, and then commands, right? And before we leave now, what I'll do is I'll show you that if I convert this to spaces, let's say 2 spaces in this case, and execute the recipe again, uh, you know, make is complaining. We see make complaining, missing separator on line number 10, right? So it looks like things are good, but they're not. We should have a tab here, right? And the other thing I want to do is call this, something else. Let's say I call it 𝘁𝗵𝗀𝗀𝗚. So now when I do this, he says, hey, okay, let me also remove test.txt, right? When I try to do this, it says, hey, I found no rule, because it found no makefile, right? And now what I'm going to do is I'm going to pass it the -f 𝘁𝗵𝗀𝗀𝗚𝗏, and now all of a sudden it knows how to execute. So -f is the flag that we can pass a custom makefile that is not having the name makefile. If it is not named this, then this is how we pass it. So hopefully you're clear with what the make utility does and how the make files are to be used. This is kind of just FYI for young professionals. They kind of, in the past, have seen that people don't understand what make files are used for. So this lecture was specifically to call that out. Now let's do one thing, which is let's leave our environment the way we had found it. And let me also go ahead. Okay, actually, let me remove and let me change this to makefile. and we are good. So we are leaving our environment the way we found it. And with this, in the next lectures, let's explore the other utilities that we were using.